Hey everyone. So this video is going to be something quite different today, and I'm pretty sure it's going to attract a significantly different audience from my past 200 or so videos. So I feel it'd be good to introduce you all to what I normally do on this channel first. So on this channel I talk about three things. The first is beer money apps, which are apps used to make a little bit of money, enough to buy a beer. You're probably knowing this from seeing the intro channel video that I still have up if you just go to the page if you haven't subscribed yet. Second, I take the money earned from those apps and I invest them into stocks, bonds, crypto, real estate, gold and silver. Well, the last three as of right now I haven't done yet, but I plan to do it very soon. Crypto in particular, I'm going to have a sliver of Bitcoin very soon, actually. But the third thing I talk about, most importantly, is the math behind things. I love numbers. I love figuring out probabilities of situations. I love looking at finances and trying to compare where I keep up with others my age or income. The only thing about numbers I don't like is filing taxes, obviously. And today I'm thinking about going rather math heavy, taking a break from beer money for a little bit, and talk about that enjoying life part of the channel I mentioned on the intro for one video. Last time I did this was the Christmas Q&A, so it's been a good 5 months or so. I'm going to talk about a project that I have been doing over the month of April. So if you all allow me to indulge myself here, let me get to how this came about. So I've talked about this YouTuber before. His name is KamSandwich. He is a YouTuber who talks mostly about college sports, Butler College basketball, and has since pivoted to talk about board gaming. Now, I found him while setting up the Beer Money Mania event, right after I uploaded my first video announcing that I was going to have the Beer Money Mania event. On my recommended feed, immediately following that, I saw a video from his for the worst board game of all time community tournament. This was the selection show at the time. Now, I won't spoil for you how this tournament went. You can check it out on the link below in my description. It features a bunch of interesting entries like the randomized color duo of Candyland and Mr. Bacon's Big Adventure, Sorry, 2 of the Monopoly clones, 2 Psychology clones, Group Therapy, and the Ungame. The campaign for North Africa, which will take you 20 years of board game nights to play, and I am not exaggerating on that one, and so on. Anyway, the game I want to look at today was one of the participants, and because of how simple it was and how easy it was to simulate, and just because I wanted to find a good answer for a couple questions that was in my head at the time, I thought it'd be good to look at it a little bit more and the math behind it. And that board game is called WWB. Now, WWB stands for the World's Worst Board Game. Don't worry, we're not going to talk too long about the board game. It's just going to take me barely a minute to explain the rules for WWB. So, first off, the board basically consists of 102 squares. There's start, there's scores 1 to 100, and a finish. You actually have to take post-it notes, I believe, or cards, and actually write the numbers yourself, and actually make the game yourself. That's how the game's actually made. Anyway, players take turns rolling 1 die. Now, if they don't roll a 5, they do nothing. If they do, they advance to the next square. So if you're in start, you go to 1, 1 to 2, and so on. They then roll again. If they don't get a 5, they must go back to start. Otherwise, if they do, they stay put. Now, the only other rule here is if 2 players are in the same square at any time, both players end up going back to start regardless. And the first player to cross the finish line is the winner. Needless to say, this game is going to take you a terribly long time. So yeah, imagine needing to do 101 pairs of 6s in a row. That's what you need to do in order to win this game, but how long would it actually take to beat this game on average? Well, that's where the simulations come in. So, I went on Board Game Geek originally, and there was a user there by the name of Ethan Nicholas who had made a computer simulation of WWB way back in 2012, and in that simulation, he got player 1 up to 13, approximately 28 billion turns in. I haven't seen any simulations since, so I thought, hey, I'd give this a shot. Why not? So I had explained that to KamSandwich during his tournament, and I realized that something like this was going to take a very long time. and I'm very aware that getting to the finish line was going to be impossible. I mean, just having a player get to spot 14 and stay there was all I needed to do to kind of put my place in as the guy that's gone the furthest in WWB. And computers have come a long way from 12 years ago, so you'd think it wouldn't be a problem, right? So, challenge accepted. I decided to start by programming a simulator in Python. On top of the actual game itself that I simulated, I also added a data saver. So in case my computer crashed, the program crashed, or so on, it would load back the data and continue playing. Thinking that since Ethan got to simulate 28 billion turns in about 7 minutes, I should be seeing way more than that, right? Well, I'll show you the results from that first game that I played back in March while the tournaments were being played, and yeah, no. I was actually going way slower than Ethan, and I wasn't quite sure why. During that time, player 1 managed to get to spot 13 on the board alright, and on turn 48.9 billion, tying the record. Player 2 was right behind with 12, but I knew that something was amiss. Python was much too slow for what I needed done. To give you an idea just how slow we're talking about, I got to this many turns, 48 billion, in approximately 12 days. And I did have one more day of simulation. It got to about 53 billion, and then it kind of stopped, averaging about 4 billion turns per day. By comparison, Ethan over here, if you see the 28.8 billion turns, he got there in approximately 6 minutes. So clearly I was doing something very wrong. So I wanted to get something a little bit more lightweight, and so I decided to translate my simulation to C. I remembered hearing from a friend that C was a lot faster for simpler tasks because there wasn't as much assembly code behind each one, and also I have quite a bit of experience in C as well, so I did that. I also added a log on top of a data saver so I could keep track of milestones in a single file in case the game crashed. The only thing that stood in my way was the big numbers. You see, I wanted to keep this package small enough that I wouldn't have any issues, and I thought about doing a 64-bit integer, but I had an even better idea. So, if I kept it at 32-bit integers, it would stop at turn 2 billion, and that would probably end within, like, I don't know, half a day or something, maybe even less than that. So I made 3 32-bit variables for the numbers. The first bit would calculate the number of turns, the second bit would calculate the number of billions of turns, and the third variable would calculate the number of billions of turns, or quintillions of turns. Now, I realize this third variable was probably not really necessary, but I left it as a nice to have. Who knows if I would ever get to 1 quintillion turns after all. So I did run this, and it definitely ran much faster. About 900 times faster, in fact. I let it run for a couple weeks on my computer uninterrupted, and I'm about to show you the play-by-play of this game. Now, to show the results and make it a little bit interesting, since I do have a newer audience here, and I wanted to entertain a little bit today, I decided I'd give these two players names. So, when I first told Cam about this project of mine, he became a die-hard Player 1 fan, so I feel like it's only fair to make him Player 1. Now for the second player, I need something a little more beer money related so that I can tie it together. So who would be a good player 2? Mario? Luigi? Ah yeah, Crypto Luigi from Atlas Earth. Well, this is technically the animated version of Derek from all the Atlas Earth commercials he does, but I know a lot of people just nickname him Crypto Luigi, at least the animated version of him, so I'm going to go with that name. I also will be recording only the furthest milestones for each player, since about 95% of the time, both players will be at the starting square, and 90% of the remaining 5% of that time, they'll be on square 1, so not exactly exciting to show the turn-by-turn, play-by-play. Milestone by milestone it is. Alrighty, now that the players are set, here we go! Crypto Luigi gets off to a good start getting to square 3 by turn 57. The very next turn, KamSandwich manages to roll 2 consecutive 5s and stakes a claim on square 1. 7 turns later, he closes the gap to 3-2, and then ties it up 58 turns later at 3-3. From there, a bunch of nothing until Crypto Luigi retakes the lead on turn 26,305, making it 4-3. KamSandwich ties it up around turn 49,000 at 4-4. This means that both players have managed to get 4 consecutive pairs of 5s to get to 4 before going back to start. Around the 63,500th turn, Crypto Luigi manages to hit square 5 and stay there. KamSandwich matches it about 29,000 turns later. Nothing much until turn 239,794, where Crypto Luigi reaches square 6, and KamSandwich answers about 500,000 turns later. Kam then takes initiative about 2.2 million turns later and is the first to hit 7. Crypto Luigi matches it 3 million turns later on turn 6 million. If they were playing this in real life, by the way, and both of their turns lasted an average of 5.5 seconds, at this point they would have played nonstop for almost a full year. Next, we go to turn 12,322,232, where Crypto Luigi reaches square 8. And Kam will answer only 7.6 million turns later. Over the next several turns, though, KamSandwich goes on an absolute tear, hitting 9, 10, and 11, opening up an 11-8 lead on Luigi. 30 million turns pass. Crypto Luigi then closes it to 11-9. It takes him another 410 million turns to close it to 11-10, and another 1 billion turns after that to tie it up at 11, and then another 10 million turns to finally take the lead. Gotta be feeling for Kam here, going almost 32 billion turns before hitting another milestone, and catching up to tie at 12. Crypto Luigi answers on around turn 53 billion to take the lead back at 13, and becomes the first player simulation or otherwise to reach square 14 on turn 103,428,876,289. And by the way, we're not done. Kam gets to 13 100 billion turns later, and then 2.1 trillion turns later hits 14. Now, to give you an idea just how many turns this is, at this point, both players only being at 14, only 1/7 of the way to the finish line, and they have played 2.1 trillion turns, which, if each turn lasted 5.5 seconds on average, and by the way, I have experimented this with my wife. We've actually played like 50 turns and had averaged out the number of seconds based on that, and it came to about 5.5 for both of us, that is, to take our turn, that is. That means they would have played nonstop for around 366,000 years. On turn 3.2 trillion, Crypto Luigi breaks 15. Kam won't answer until around turn 12.34 trillion. Then 21 trillion turns later, KamSandwich does it again, breaking 16 and 17 in near consecutive turns, becoming the first to get 1/6 of the way through the game on turn 35,409,637,192,659. Then another 13 trillion turns passed before the game crashed. Now, you would think that the data file would be fine and I could go back and start playing again, but turns out the game is having trouble running and the game just keeps crashing. So I decided to call it there. After about 49 trillion turns, the equivalent of a game lasting approximately 12.4 million years, Kam gets the furthest with a final score of 17-15. So I did it. I got one of my characters to go the furthest in WWB legit that anyone has ever gotten to. But I was still a very long way from finding out the average number of turns it would take to get to the finish line. At this current rate, I'd be dead before I got to score 25, so I decided to do what any math nerd would do in this situation: projection through experimentation. I would have Kam and Luigi here play some short games, starting out first with a short game with start 1 to 10 and finish, and have them play over 5,000 of these games on the computer to get an average number of turns. I then took out the highest number after each grouping and had them play increasingly more games to get better averages, all the way down to the simplest game I could play, which is a 3-square game of start, 1, and finish, because simply start and finish is just a battle to see who could roll a 5 first, and we already know how many turns it would take for someone to win on average. Now, I'm not going to be that guy and recite every single number of turns in each game where the highest number in the game was 10, 9, 8, all the way down to 1, and technically it's actually a +1 on that because the finish line counts as the +1. But here is the average number of turns for each game and the number of games they played, and the first thing I'll say right now is Crypto Luigi did get his revenge, winning about 50.3% of the nearly 600,000 short games they played. That's irrelevant to what we're looking for, but I thought it was just interesting considering he always wins second every single game. But I guess in a game of millions of turns, first player advantage doesn't really matter all that much. One major observation you'll probably notice from the average numbers, however, is the multiple from one game to the next. Starting with the game with the highest number being 1, so that is the start 1 finish, the average number of turns to finish this game is about 43. Now this should make sense because you have a 1 in 6 chance to advance to square 1 and a 1 in 6 chance to stay there. So getting yourself to square 1 in position to cross the finish line will take you 2 5 rolls in a row. It's just 1 in 6 times 1 in 6 for an average of 36 turns, 1 in 36. Then provided you don't collide, it'll take you an average of about 6 turns to cross the finish line. The expected value of the number of turns is approximately 42 in this case, so close enough. However, as we lengthen the game, the average number of turns to win the game goes up by a multiple of a little more than 6. Now, why is that when we started with 36, the 1 in 6 times 1 in 6? Well, let's take a look at how the turn is played. The first half of the turn, you're trying to roll a 5 to advance to the next square. The thing is, no matter what, you're going to advance that square eventually. It will take you an expected value of 6 turns in every single scenario to advance to that square guaranteed. It's staying there that is the issue. And those second half of rolls must be a 5 consecutively in order to stay there. And in probability, that is where the odds multiply. In a game of start 1-2 finish, for example, getting from 1 to 2 is a guarantee. Staying in 2 is a 1 in 6 chance, just like staying in 1 would be. So why a little more than 6? Well, 2 reasons. As the game gets longer, we do have to worry about collision, and the most likely collision by far is when a player in start rolls a 5 to advance to square 1 to meet the other player who is currently in 1, knocking them both back to start. This doesn't happen super often though, and any other types of numbers would be even rarer than that. And the other reason for the increase in the multiplier is that first half of the turn. Every 6 turns, you will roll a 5 to advance to the next square, no matter what square you are in. Now, I'm lazy, and I need to start investigating a Bitcoin app for my next beer money review. So I don't feel like trying to figure out the exact formula that would solve this, so I just approximated the multiplier by taking the average amongst the turns that I've seen. So for example, the game to 2 averaged 292 turns. The game to 3 averaged 1,792 turns. So what I'll do is I'll take the game to 3 average turns and divide it by the game to 2 average turns to find that multiplier from 2 to 3, and that turned out to be 6.13, and I put it in as data. I did this for each multiplier in between the lengths of games, and the average I got was about 6.17. And thus, here's the formula for you. It takes 43 times 6.17 to the x minus 1, where x is the highest number in the game. Now, I did x minus 1 because 43 is the number of turns under the start 1 finish rule. Now, I did run a few more set simulations to get this average because I was feeling a little shaky about these shorter games, because especially the 1 to 2 multiply was extremely high compared to the others. They were a much shorter sample though, and only served to increase the number of games played from almost 600,000 to around 1.4 million, which Cam did manage to eke out a 50.1 to 49.9% win, in case you were wondering. So back to the original game. We're going to use our poor man's model and calculate the expected number of turns it could take to get to the finish line of the full game of WWB, which the highest number in the full game is x equals 100. That means x equals 100 minus 1 makes 99, so 43 times 6.17 to the 99th power gives us an expected value number of turns of approximately 7.442 times 10 to the 79th turns, or 744.2 quinvigintillion turns, which is about 25% smaller than the number of atoms in the known universe. Given an average back and forth turn of 5.5 seconds, again verified by me and my wife, it would take you, on average, 1.297 times 10 to the 73 years to finish a game. And my computer won't fare much better. Given the C version, the fastest version that I made, zoomed through approximately 4 trillion turns a day, it would take the computer approximately 2.8 times 10 to the 65 years to finish the game. Now again, this isn't an exact science, but it's the closest I'm willing to examine, and will give you a good ballpark estimate of just how ridiculously long this game is, and why it's such a time waster. So much so that it puts the campaign for North Africa board game to shame. Of course, I wouldn't recommend wasting time there. If you want a time waster, you can check out the apps on this channel to get time wasters that actually are worth something and pay you some money, or check out other videos here. This took a lot more research than I expected, so I really hope you like this video, and comment and let me know if you like this video. I know it was a huge stray away from what I normally do on here, but everyone had been asking me to do a video on it, so I thought, why not? And don't forget to subscribe to Beer Money Engine. Now we're going to ease back to the financial money stuff with a personal finance video on Saturday, and then of course Atlas Earth stuff the following week. I'll see you all then. Bye everybody.